Welcome to the Shikasa Boo Motor channel. This channel provides easy-to-understand explanations of car mechanisms. Toyota has two types of hybrid systems. One is the system used in vehicles like the Prius, and the other is paired with a 2.4-liter turbo engine. This might get a little complicated, but in the past, Toyota classified the Prius system as a power split type. However, for the past few years, they have been classifying it as a series parallel system. Honda has a hybrid system that's completely different from Toyota's, but they also classify it as a series parallel type. Furthermore, this system is referred to differently depending on the market, with names like Synergy Drive or THS2. The system paired with the 2.4-liter turbo engine is classified as a parallel type, but in the market, it's referred to in two ways: Hybrid Max and Dual Boost Hybrid. Therefore, in this video, we'll refer to the Prius system as a power split type, and the system paired with the 2.4-liter turbo engine as a parallel type. Each of these hybrid systems also has a version for rear-wheel drive, but since the operating principles are the same, this video won't cover them. Depending on the market, Toyota uses the power split system in the majority of its models. The parallel system is limited to certain models, such as the Crown, Highlander, and Lexus RX. The power split system consists of an engine, a planetary gear set, motor generator 1 primarily responsible for generating electricity, called MG1, and MG2 mainly responsible for driving the vehicle. The planetary gear set serves to split and combine the driving force from the engine and MG2, and also functions as a CVT, continuously variable transmission, when the engine is driving the vehicle. This channel offers a detailed video explaining how the power split system works. If you're interested, please check it out. The link is in the description. The parallel type system consists of an engine disengagement clutch, a drive motor, a launch clutch, and a 6-speed stepped automatic transmission. The diagram makes the system look quite large, but the transaxle is actually very compactly packaged. Let's take a closer look at their operation. At launch, both systems drive the vehicle using the drive motor, and the vehicle continues to run on motor power up to a certain speed. In the power split system, the drive motor's rotation is transmitted to the wheels, because the planetary gear set is freewheeling. In the parallel type system, engaging the launch clutch allows the drive motor's rotation to be delivered to the transmission. When the vehicle speed reaches a certain level, both systems start the engine. In the power split system, MG1 functions as a starter motor and cranks the engine through the planetary gear. In the parallel type system, the drive motor cranks the engine by connecting the engine disengagement clutch. When driving using only the engine, the operation differs depending on these systems. In the power split system, MG1 operates as a generator, and by varying its load, it's possible to change the output speed to the wheels while keeping the engine speed constant. In other words, the planetary gear functions as a CVT. In the parallel type system, the engine rotation is transmitted to the transmission by engaging two clutches. The transmission shifts between first and sixth gear depending on factors such as vehicle speed and throttle opening. The motor operates as a generator, supplying power for battery charging and the vehicle's electrical systems. When strong driving force is required, such as during rapid acceleration, the output of the drive motor is added to the engine output. During deceleration, both systems generate regenerative braking. In the power split system, MG2 operates as a generator, and its resistance is used as braking force for the vehicle. In the parallel type system, regenerative power generation is carried out by disconnecting the engine disengagement clutch and operating the drive motor as a generator. This section will focus the gear shifting behavior during engine-powered driving, which is the biggest difference in the operation of these two systems. Let's take a look at the CVT operation of a power split system. The engine is connected to the planetary carrier of the planetary gear set, MG1 to the sun gear, and MG2 to the internal gear. Power is transmitted from the internal gear to the wheels. Even if the planetary carrier rotates at a constant speed, changing the rotational speed of the sun gear will change the rotational speed of the internal gear. In other words, it's possible to change the vehicle speed by varying the load on MG1, which operates as a generator, while keeping the engine speed constant. Let's take a look at the relationship between the accelerator pedal, engine speed, and vehicle speed. When the driver depresses the accelerator pedal, the engine speed remains constant while the vehicle speed increases. It can operate in the engine's high-efficiency rotation range, so it offers excellent fuel economy. However, because the accelerator pedal input, engine speed changes, and vehicle speed changes are not synchronized, the driver may feel a sense of discomfort. This phenomenon is known as the rubber band effect, and it's considered one of the weaknesses of CVTs. In stepped automatic transmissions, the accelerator pedal input, engine speed changes, and vehicle speed changes are synchronized, allowing acceleration without any sense of discomfort. However, because the engine speed fluctuates with each gear shift, fuel efficiency is lower compared to a power split system. Another drawback is that shift shock can be felt with each gear shift. We will examine two key features of the 6-speed transmission used in Toyota's parallel hybrid system. Typical stepped automatic transmissions are equipped with a torque converter. In gasoline-powered vehicles, the rotating engine is engaged with the stationary wheels at launch. The torque converter, which uses ATF, automatic transmission fluid, as the medium for power transmission, is able to absorb this difference in rotational speed. When a clutch is used instead of a torque converter, the vehicle may experience vibration or shudder during launch, depending on the conditions. Toyota's 6-speed automatic transmission is equipped with a launch clutch instead of a torque converter. How did they deal with this issue? In hybrid vehicles, the drive motor, unlike the engine, comes to a complete stop when the vehicle is stopped. By engaging the stationary drive motor to the stationary wheels using a clutch, and supplying current to the motor, the vehicle can start off smoothly. In gasoline-powered vehicles, it's now common for automatic transmissions to have 8 to 10 speeds. Considering the price of Toyota's parallel hybrid models, 6 speeds seems too few. We will compare Toyota's transmission with the 8-speed automatic transmission in the BMW X3. Of course, since the number of steps is different, the BMW has a wider gear ratio range. Toyota's first gear ratio is much higher than BMW's, and the spacing between gears is wider. Assuming the same engine is paired with these transmissions, Toyota's acceleration from a standstill is slow, and the shift shock is more pronounced. How did Toyota resolve these issues? These graphs represent the torque characteristics of a typical gasoline engine and electric motor. Electric motors generate maximum torque from 0 RPM through the low speed range. For this system, which launches with an electric motor, a high first gear ratio is not much of an issue. Shift shock can be mitigated by having the drive motor apply torque at the moment acceleration is interrupted during an upshift. By taking advantage of the characteristics of hybrid systems, Toyota has achieved smooth and powerful acceleration even with transmissions that have relatively few gears. Toyota achieves 6 speeds by combining one standard planetary gear set and one Ravino's-type planetary gear set. This channel offers a detailed video explaining stepped automatic transmissions. If you're interested, please check it out. You'll find the link in the description. Finally, for reference, let's compare the performance differences using the Japan Spec Crown crossover. Toyota offers 2 types of systems for this model, a power split system and a parallel type system. The power split system uses a 2.5-liter naturally aspirated 4-cylinder engine, while the parallel type system is equipped with a 2.4-liter turbocharged 4-cylinder engine. The power split system is paired with an eCVT, while the parallel type system comes with a 6-speed stepped automatic transmission. The power split model weighs 1,810 kilograms, while the parallel type model weighs 1,910 kilograms. The parallel type model appears to be slightly heavier. The engine output for the power split system is 137 kilowatts and 221 newton meters, while the parallel type system has 200 kilowatts and 460 newton meters. The turbocharged engine is truly overwhelming. Drive motor output. Both models are equipped with electric 4WD, so they each have a drive motor at the rear as well. The power split system has a front motor producing 88 kilowatts and 202 newton meters, and a rear motor producing 40 kilowatts and 121 newton meters. The parallel type system has a front motor producing 61 kilowatts and 292 newton meters, and a rear motor producing 59 kilowatts and 169 newton meters. The significant difference in total system torque leads us to anticipate a difference in acceleration performance. 0 to 96 km per hour acceleration time. Please be note, this is not an official statement from Toyota. These figures are based on several websites, but the values may vary slightly depending on the testing conditions. Therefore, please focus on the difference, not the absolute values. Indeed, the difference in torque translates to a difference in acceleration performance. Fuel efficiency. Please note that the fuel economy for Japan market vehicles does not include the extra high-speed phase at 130 km per hour in the WLTC mode. Needless to say, the power split system overwhelms the parallel type system. By offering two systems, one prioritizing fuel efficiency and the other drivability, within a single model, Toyota proves why it is the king of hybrids. Thank you for watching. If you enjoyed this video, please consider subscribing to the channel. We'll see you in the next video.